Second salvo, 200 yards short. Third salvo, on target.
Long before Pearl Harbor, the Signal Corps of the United States Army knew it would take more than a telephone wire to connect this voice with all the other fighting units that had to hear it. They knew it would take radio transmission. Radio can reach these tanks wherever they are and tell them what's ahead. A radio transmitter could coordinate the movement of troops, bring tanks and infantry together at the right place at the right time. But it would have to be a mobile radio transmitter. And it would have to be a powerful transmitter to keep an unbroken contact between our forces on the ground, in the air, and on the sea. The control of widely separated forces, the timing of their action, the success of the attack depends upon reliable radio communication. Yes, the Signal Corps engineers knew just what kind of a transmitter it would take to do the job. But the big problem was to locate a manufactured transmitter of a design that would come close to these requirements. In this pre-war Hallicrafter's HT4 transmitter, the Signal Corps found many of the answers. It was designed especially for amateur use. It was easily capable of worldwide communication using either code or voice. Another great advantage was the fact that this Hallicrafter's unit had been on the market for several years. There was an opportunity to check its performance through the records of hundreds of America's hams. And these amateurs know good performance. It employed band switching in the exciter and driver stages, which made it possible to change frequencies very rapidly.
Say W2 USA, W4 GWG calling 20. I'm sorry, I have to interrupt. 4G George, repeating me now, W2 USA. The center of the traffic is hello 20, hello 20, back to you, or you stand by, because I'm out in the control making a station break. I wonder if you're still receiving the red station, and I will read 25. Calling 20, otherwise, calling any 20, calling any 20, I'm not sure that you're hearing me. But I would like to...
Hello, CQ. Hello, CQ. This is W9WZE Chicago, W9WZE Chicago, calling CQ for any 20-meter phone and standing by. Go ahead, please.
Hello, W9WZE Chicago. Hello, W9WZE Chicago. This is W6QD, Los Angeles, California. W6QD, Los Angeles, calling W9WZE Chicago. Go ahead, Bill.
Hello, W6QD, Los Angeles, California. This is W9WZE Chicago coming back. Good evening, Herb. Your signals are coming in fine tonight. R5S9. By the way, Herb, what are you doing on 20-meter phone? I thought you always worked CW. Now let's hear something about that marvelous California weather, eh?
Alaska, Australia, Europe, South Africa. These were regular, almost daily experiences in many amateurs' homes, where Hallicrafters were rapidly shrinking this old world of ours. The transmitter that serves the Army must be able to perform anywhere and under all kinds of unpredictable conditions. Up to this time, no one had ever thought seriously of putting this sensitive, finely balanced instrument on wheels and bouncing it around foxholes. What about vibration? Where would the power come from? The job of toughening up the HT-4 to go to war fell on the shoulders of Bill Halligan, Bob Samuelson, Hallicrafter's chief engineer, and the hard-pressed technicians of the Signal Corps. There were few changes needed to adapt this unit to Army needs. There was good engineering and good sound construction in the set to start with. This was to be the new home for Hallicrafter's equipment. Everything needed to transmit and receive had to be packed into this small space. That would take some more good engineering. This demand was nothing new to these pioneers. There are no fixed limits in Hallicrafter's design or construction. There is always development, change, improvement. Many of the war adaptations were drawn from advanced developments that had been in the experimental stage for months. For example, in the pre-war model, plugging in a tuning unit might be quite a trick if the holes in the prongs couldn't get together. For the new Signal Corps transmitter, guide channels made this tuning unit change quick, positive, and held the unit securely in place. In the pre-war model, the prongs on the tube were enough to hold it in place. But this won't do for hopping shell holes. A tube support or ring was added to lock the tube firmly in position so that no amount of bumping or vibration would move it. For stationary use, no special footing was needed to anchor the transmitter. But for rough riding in a truck, rubber shock-proof mountings were added. In the process of making the entire unit more rugged, this air padder was replaced by a new vacuum tube padding condenser. Rooftop antennas could be as large as the pre-war ham wanted to make them, but it was pretty obvious that a rigging such as this one would hardly do on the top of a Signal Corps truck. The solution was in the use of whip antennas and in designing an antenna tuning unit which would efficiently transfer the output of the transmitter to the whip antenna. Throughout all of these changes, to adapt a peacetime transmitter to wartime requirements, the high-quality standards of Hallicrafters were strictly maintained in workmanship, in design and construction, and especially in performance. When the Signal Corps inspected the first of Hallicrafter's transmitters armored for war, they found what they were looking for: a high-powered unit that had been made completely mobile, one that delivered good, reliable performance under all conditions. The first big job had been done well. Then came the warning of another bigger job. Field reports indicate performance of SCR-299 exceeds expectation. Request you expedite production as much as possible. And in working man's English, that means let's go on production. This is the plant in Clearing, Illinois, where mass production of the new SCR-299 mobile radio station was obtained on a scale never dreamed of before in this industry. The key men for this tremendous production job were selected from the ranks of the American radio amateurs. These men had the know-how, the technical background and experience it took to get into action fast. This entire operation is headed by Herb Hartley, known to the amateur fraternity as W9WNG. This production was accomplished through the splendid cooperation of hundreds of loyal, skilled workers who realized how big the job ahead was and knew how to do it. It was achieved through the unfailing efforts of many suppliers and their thousands of workers who built the tubes, the transformers, the condensers, coils, insulators, the steel chassis, and all the other components that go in to make the SCR 299. And finally, the very design and construction of the transmitter lent itself to mass production better than any other pre-war domestic transmitter. The chassis was strong. There was room to work with sub-assemblies. This is the main assembly line, from the end of which come the completed transmitters. This is the feeder table for the main assembly line. Here the sub-assemblies are inspected or hooked up to other components. At the foot of the main assembly line, the transmitter looks like this: a steel base to which are added sockets for rectifier tubes. Then the bleeder resistor, which furnishes a constant load on the high voltage supply. Next, the filter choke and condensers, which supply direct current to the plate circuits of the transmitter. In wiring these parts, a great deal of time and work is saved by the use of pre-formed cables. The cables are cut, formed, and tipped, all ready for installation. And here's the base assembly, completed in just a little more time than it's taken to show it. Meanwhile, on the opposite side of the table, the power control panel is being assembled. These are the controls for filament voltage and modulator bias. The purpose of this panel is to group, within convenient reach of the operator, all the essential power controls. These cables here are cut to length and form over on the feeder table. Terminal lugs are soldered to the ends. Then all the other wires needed in the circuit are placed into position, bound together, so that soldering to terminals is the only operation needed in the final assembly. This is the power panel cable. When wiring is completed and the switches and fuses have been installed, the sides are joined to the power control panel, and this unit is ready to join the main assembly line. The transmitter begins to take shape as the base is joined to the power panel unit. Electric hoists are used for ease and accuracy in handling these parts. Now the main power transformer is set in place. This is the unit that steps up the input to the high voltage required to operate the final amplifier and modulator tubes. After the transformer is connected, the entire deck or base is hoisted to a dolly to make handling easier. There's high power equipment on this deck, and it's heavy. The second deck contains the audio driver stage and modulator of the transmitter, which makes possible radio telephone operation. This entire unit, built in another plant, has been inspected on the feeder table and requires only a modulation transformer and the phone CW relay to be complete. The top deck of the transmitter, the radio frequency section, begins with the installation of the exciter assembly, which is fabricated at Hallicrafter's 26th Street plant. 3 separate tuning units may be plugged into this assembly, any one of which may be selected by the band switch.